Hey everybody, welcome to video 17-1B. We're going to be working with Explain 2 here in your book on page 891, but before we do, I want to do a quick algebra review of completing the square, the idea behind completing the square. So we're going to go to our visual of literally a square, okay? And a square, as you know, has to have the exact same length and width, obviously. So what we're going to do is we're going to try to start with a rectangle and figure out how to make it into a square. So if we had a rectangle that was, let's say, a square plus a bunch of little rectangles following it, and I'm going to use the example of, let's say, let's go with 6 different rectangles, tiny little skinny rectangles following it. This is the idea of your algebra tiles, okay? So the area of this square right here, because it has a distance of x by x, the area is x squared. Now each one of these tiny little rectangle tiles here has a width of 1 going all the way across. So if we have 6 of them, then of course this area of all of these pieces here is 6 times x. So what we would like to do is we would like to change this rectangle shape here into a square. Now, the way to do that, because we need to head toward the length being equal to the width, is that we need to basically take this extra part outside of the perfect square that we already have and kind of cut it in half right down the middle here. So we're going to take 3 of these little tiles and we're going to relocate them down below the square so that we've kind of evened out the dimensions of our shape. So again, this is all gone here, and now what we have is basically a square, the same area 6x, but now is split so that part of it is here. We've got 3x on the right of the square and 3x below. But as you can see, we've got a really big area here that's missing. We've got this whole square right in here that has not yet been filled in, that kind of needs to be filled in, so that if I thought about the entire picture of completing this bigger square, I want to know how much needs to go in that bottom right-hand corner. Well, I think you can see from the calculations and the picture that we have here that that square, if I were to fill in its kind of its dimensions, that would be a square that would have a 3 by 3 length and width, and so that area right there has to be 9 more pieces added to make the rectangle into a square, basically. And where we got the 9 from, remember, is that we took the initial amount of tiles, which was 6, we cut it in half, and then we took that as our length and our width, that of course had to be multiplied to get the area of that tiny black square down in the corner. So what does that all mean? Well, you guys, that all means that when we are thinking about completing the square in algebra, we have an equation that might start something like this: x squared plus bx, and then we want to basically figure out what's that magic number that is going to complete that square. Well, we use the example of 6, but if we made this into, back here, our example was just a b to begin with, plus some sort of bx, okay? So we've got our tile, our x squared tile here, plus an unknown number of tiles going this direction. Let's call it b times x. Well, what we would have done is we would have cut that b number of tiles in half, still moved half from over here down to underneath to try to even out the dimensions, and then we would now have the dimension of the smaller black square that we needed to add, that instead of 3, we would say that's just half of b for both of those dimensions. So the idea behind completing the square is that if you have a squared term plus some value of bx after it, then all I have to do to complete the square is add the value of b divided by 2 all squared. And that's like adding in the area of that small black square in the bottom right hand corner. So what would I do? Let's do a couple of quick examples of that before we start using this in the case of the circle. So we would have something like this. If we had, for example, x squared plus 10x, and we wanted to know what value would complete the square there, well, we would take our 10, we would cut it in half, and we would square that. So order of operations, first divide, 10 divided by 2, that would become just 5 all squared, or we would add 25 in order to complete that square. And again, using some algebra terminology, we would have two terms, or a binomial, one of which was quadratic or squared. The other one is a linear term, or just x to the positive 1 exponent if we were going to put one there. We always want to take and cut in half the coefficient of that just plain old x linear term. Take that number off, like we did, divide it by 2, that's the evening out of the dimensions of the circle, and make it into a square, or literally square the number. We get 5 squared, and then we add 25. Let's do another one. If we had x squared, let's say, plus 12x, what would we add? Well, we would cut the 12 in half, and we would square it. So we would have to add 36, because that's 6 squared. You guys, the same thing holds true if we have a negative value for our linear term to begin with. So let's say we had something like this, x squared minus 8x. Plus what would make that a perfect trinomial square? Well, we would be able to still take the value in front of the x. In this case, it's negative. We would cut it in half first, and then we would square it. What does that become? Well, that becomes negative 4 all squared, or of course 16. Notice every time we're completing the square, we should be coming up with a value that is positive every time. Let's take a look back. In this case, we had plus 25. Yep, that's positive. In this case, we had plus 36. Yep, that's positive. In this case, I started with a plus sign and we weren't sure whether maybe it was going to be positive or negative, but notice every time we have a negative and we square it, we still get a positive value, and we had 16. Yes, that's positive. So you'll see in the setup for Explain 2, they're always automatically putting a plus sign in front of it as we use it in the equation. That's why. It doesn't matter. It's always a positive value. So I hope that gives you a little bit of background of just the idea of completing the square. You did do it in algebra, but it's been a little while, I know, so thought it would be good to refresh that. All right, let's get going on our book page now. Let's go to page 891, please. On page 891, we are looking at Explain 2, where we are taking the equation of a circle and moving backwards to find the center and the radius. As you know, in the previous video, we just kind of handed you the center and the radius, and you were coming up with the equation using Pythagorean theorem. In Explain 2, we're going backwards from the equation to the center and the radius, which means we need to pull out h and k from this equation. Well, remember, It was x minus h all squared and y minus k all squared that resulted in the equation of the circle. What we didn't do in the last video is that we didn't expand that idea so that it was x minus h times x minus h, and then using our distributive property to kind of expand that all out into the 3 or 4 terms that it would have become. What we're starting with here in example 2 is a partially expanded version of the equation. So here, let's work through some steps. As we look at part A says take this equation, x squared minus 4x plus y squared plus 2y, and we need to figure out what the center and the radius is of that equation if it's equal to 20. So what we want to do is we want to complete the square, and notice that it says we actually want to do that twice, okay? Why are we doing that twice? Well, we actually have 2 different variables that we're working with. So we're going to complete the square for the x terms and for the y terms. And remember, our goal is to get it back to this general equation for the center and radius put into the equation of a circle. So we're going to take our x squared minus 4x, and we're going to pretend that that is our x squared plus bx for our x terms, and that our y terms are y squared plus by. Now remember, we talked about taking the b value, or the linear term each time, cutting it in half, and plugging it into the equation. So notice what they're starting us off with here as our setup in step 1. We would have x squared minus 4x plus something squared. That's the perfect number that's going to complete the square. We'll figure that out in a second. Y squared plus 2y plus something squared. They're kind of leaving a fill in the blank for you. And then whatever we do to one side of the equation, we've got to do to the other. And I actually think that we should, you guys here, probably go back and add a second parenthesis squared, if I were you, because that'll keep in mind that, again, the idea of what I add to one side, here's the other, here's what I added to the other side as well. So we're just kind of keeping left and right sides in balance, right? Because there's 2 values that we're adding to the left side, so there should be 2 values we're adding to the right. Your book kind of combines that into one, but I think it's best to visually separate it, at least at first. So in the next step, right here, we're trying to figure out what is that perfect number that we're adding. So here's my b value, -4. We need to cut it in half and square it. So that's what you see being added here. -4 squared, -4 divided by 2 squared. Same thing for y. We want to take our b value, or our linear term for the y, cut it in half and square it. So that's 2 over 2, or 1, squared. And notice whatever we've done to one side of the equation, we've also added over here to the 20 that was there to begin with. Okay? Now just becomes a simplification game. So we have x squared minus 4x plus 4. And remember that, if we were to condense it, would have the dimension of not all of the b terms on one side, but half of them. So that's x minus 2 all squared. Same thing for the y's. We would have y squared plus 2y plus 1, which is going to condense or get rewritten as the length. Instead of having 2 rectangles next to the square, we only have 1 because we've evened it out, or half of those. And then, of course, we're going to add 4 and 1 to the right-hand side as well, or combine that to plus 5, and we get 25 is the simplification of that. So if we're looking at this equation right here, we're going to go backwards, and we're going to figure out h and k. So we have x minus 2 all squared, that's my h, and we have y plus 1 all squared, that's my k. In this case, remember, it's minus 1 because it's a plus in the equation, and the equation, the standard equation itself, has a minus. So if your equation has a plus, you know that that k is negative. So h is 2, k is -1, and if I were to figure out r, it would be the square root of that value in the equation. So the square root of 25 is 5. So the center is 2, -1, and the radius is 5, and now I can graph it, and you can see the picture that they've done there. If you guys are doing graphing, I think what makes sense, just so you know, is to figure out the center. So there's my 2, -1 right there. And then it probably makes sense to go ahead and just plot 4 different points, kind of like at north, south, east, and west of the compass. So we're going 5 up from that center to put our north, 5 to the right of the center to put our east, 5 below the center to put our south, and 5 to the right, to the left of the center to put our west. I might have said to the left on east, I apologize. So it's to the right on east, south is below, and 5 to the west there is 5 to the left. Okay? And then once you have those points, then that kind of gives you a little bit of a guide to trace through to get the equation. So let's do the next example. And we're going to do part B here on page 892. Notice the equation that we start with. X squared plus 6x plus y squared minus 4y plus 4 is going to equal 0. So we're going to complete the square, and to do so it makes sense to get all the constants out of the way. So we're going to take that -4 and we're going to move it over to the right hand side. You can see that they've already kind of set that in that spot. I'm going to stick with blue for my x's and red for my y's here, just to kind of keep things organized for you. So we're going to take the linear term for x, which is plus 6, and we're going to go ahead and cut that in half. So 6 over 2, and we're going to square that. Then we're going to take our linear term for y, which is -4. So -4 over 2, and we're going to square that. Now notice what we add to the left, we've got to add to the right. So let's put our blue value in after our -4 here. So we got 6 over 2 squared, and we're going to add in the -4. Sorry, -4 over 2 squared. And of course that's what we're being prompted in the directions as well. -4 over 2 squared, switching back to blue, 6 over 2 squared. So we can keep our x value and our y value of completing the square kind of separate. Alright, so what is 6 over 2 all squared? Of course, that is 3 squared, or adding 9. And our y is, of course, -2 all squared, or adding 4. And then if we put those two values together, 9 and 4 combined, I'm going to make blue and red together make purple, so there's our combined value. And now we're going to rewrite it in the standard form. If we had 6 tiles, remember, to begin with here, like we do, we're going to split them, and each dimension is going to have 3. So we're going to say that's x plus 3 all squared. Same thing with our reds. If we had 4 tiles to begin with, as we do here for our y, we're going to split that dimension so that we have 2 on each side of our ending square. So that's going to be -2 all squared. And notice that the combination of the two, the -4 that was there to begin with, and the 13 that we balanced it out with a 9 plus 4, gives us 9. And that is our r squared. So let's identify my h. Remember, if there's a positive value in the equation for the circle, it's a plus 3 there, then because it's x minus h in the equation of the circle, the format, that's an h value of -3 and a k value of just 2. The radius is going to be found by taking the square root of the number that's in the equation, so we get a radius of 3. So the center is -3, 2, and the radius is 3. And as we graph it, we can plot those 2 points to begin with, the center to begin with. -3, +2 is right here. And we want to go north, south, east, and west. The radius distance, there, and there. and then we're going to sketch the circle with that framework. Oops, went a little bit too far east there, but you guys get the idea. I hope that that helps you understand a little bit behind what this bonus question is going to be asking for your circles quiz. Just wanted to kind of walk you through a little bit of algebra review. Hopefully it hasn't been too stressful for you. Guys, if you want to practice this problem, there are some practice problems in your evaluate set, but also please make sure you take a stab at questions 8 or 9 of your turn here if you want to practice the bonus. And there's question 9, same types. Okay? We'll see you guys next time.